What if the most mysterious message ever detected from space lasted less than 1,000th of a second, yet has puzzled scientists for nearly 2 decades? In 2007, astronomers uncovered something extraordinary hidden inside old telescope data. It wasn't a star, it wasn't a pulsar, and it certainly wasn't a known cosmic explosion. It was an unbelievably powerful radio pulse that had traveled across billions of light years before finally reaching Earth. That single flash became known as the Lorimer burst, the first fast radio burst, or FRB. The signal was so intense that for a moment it released as much energy in radio waves as our sun emits over several days, yet it vanished in the blink of an eye. Even stranger, nobody knew what created it. Since then, astronomers have discovered hundreds of these mysterious bursts. Some appear only once and disappear forever. Others repeat in seemingly unpredictable patterns. A few even come from galaxies billions of light years away, while others originate surprisingly close home. But after years of observations using the world's most advanced radio telescopes, one question still refuses to disappear. What is sending these signals across the universe? And the answer turns out to be far more fascinating than the mystery itself. When the Lorimer burst was first announced in 2007, many scientists were skeptical. Finding a signal that lasted only about 5 milliseconds sounded almost impossible. Could it simply be a mistake inside the telescope? Researchers spent years checking every possibility: equipment failure, human interference, satellite transmissions, even microwave ovens were investigated after strange radio signals at an Australian observatory were traced back to someone opening the staff kitchen before it had fully stopped. For a short time, some researchers wondered if the original burst had been another false alarm. Then everything changed. More bursts began appearing, not from Earth, from completely different regions of the sky. Different telescopes on different continents detected the same strange phenomenon. The mystery had become undeniable. Fast radio bursts were real. But solving one mystery only revealed another. These bursts were unimaginably bright. To detect them across billions of light years, the original event had to release enormous amounts of energy in an incredibly short time. Whatever produced them had to be both unbelievably powerful and astonishingly compact. Ordinary stars couldn't explain them, neither could planets. Astronomers began searching for objects capable of producing such violent flashes. One candidate quickly stood out: magnetars. These are extremely rare neutron stars, the collapsed cores of massive stars, with magnetic fields trillions of times stronger than Earth's. Their magnetic fields are so powerful that they can literally distort atoms. If any object in the universe could unleash a burst like this, magnetars seemed like the best candidate. But there was a problem. All known magnetars were inside or near our own galaxy. Many FRBs appeared to originate billions of light years away. The puzzle remained unsolved. Then came another surprise. In 2016, astronomers discovered something they never expected. One FRB repeated. Instead of disappearing forever, the source flashed again and again and again. This completely changed the investigation. If the object survived multiple bursts, then at least some FRBs could not be caused by catastrophic explosions that destroy their source. Scientists carefully tracked the repeating signal. Eventually, they pinpointed it to a tiny dwarf galaxy more than 3 billion light years away. For the first time, astronomers had a home address for one of these mysterious signals. Yet even knowing its location raised even deeper questions. Why only certain galaxies? Why do some FRBs repeat while others never return? Could there actually be multiple kinds of FRBs? The evidence was becoming more complicated, not less. As new radio observatories like CHIME in Canada dramatically increased the number of discoveries, the universe seemed filled with these hidden flashes. Instead of finding a handful each year, astronomers suddenly began detecting hundreds. Some arrived in clusters, some showed complex structures, others appeared twisted as they traveled through powerful magnetic environments, giving scientists valuable clues about the matter between galaxies. These mysterious signals were becoming more than cosmic curiosities. They were turning into entirely new tools for studying the invisible universe itself. But the biggest breakthrough was still waiting, because one day the universe produced a signal close enough for scientists to finally witness its origin. And what they discovered would transform our understanding of fast radio bursts forever.
Years, astronomers had suspected that magnetars might be responsible for at least some fast radio bursts. The theory made sense on paper, but there was no direct evidence. Then, on April 28, 2020, everything changed. A powerful radio burst reached Earth from an object called SGR 1935 plus 2154. A magnetar located about 30,000 light-years away inside our own Milky Way. For the first time in history, scientists had detected an FRB-like signal coming from a known magnetar. Multiple observatories around the world confirmed the event almost simultaneously. It wasn't as powerful as the enormous bursts arriving from distant galaxies, but it was unmistakably similar. After more than a decade of uncertainty, researchers finally had the strongest evidence yet that magnetars could produce fast radio bursts. The discovery answered one question, but immediately created another. If magnetars can generate these signals, why do only a tiny fraction of known magnetars produce them? And why are the most distant FRBs often thousands of times more energetic? Clearly, magnetars were part of the story, but perhaps not the whole story. As astronomers expanded their search, a remarkable pattern began to emerge. Every fast radio burst acts like a cosmic flashlight. As the radio waves travel across billions of light-years, they pass through clouds of gas, invisible plasma, magnetic fields, and entire galaxies. Each leaves a tiny fingerprint on the signal. By measuring how much the radio waves are delayed and distorted, scientists can estimate how much otherwise invisible matter exists between galaxies. This is incredibly important because astronomers have long known that a large portion of the universe's ordinary matter seemed to be missing. Not dark matter, but normal atoms that simply couldn't be seen. Fast radio bursts are helping scientists locate that hidden material. Instead of only being a mystery, FRBs have become one of astronomy's most powerful measuring tools. A puzzle has become an instrument. Then came another astonishing discovery. Some fast radio bursts repeat in irregular patterns. Others appear to follow cycles. One famous repeater becomes active for several weeks, then falls silent for weeks before returning again. Another source has produced hundreds of bursts over just a few years. No single explanation fits every observation. Some may come from young magnetars surrounded by dense clouds of stellar debris. Others could originate near massive black holes, where extreme gravity shapes the surrounding magnetic fields. Researchers continue testing these ideas, but none explains every known fast radio burst. The universe seems to be telling more than one story. Today's radio observatories are finding new fast radio bursts almost every week. Facilities such as CHIME in Canada, ASKAP in Australia, Meerkat in South Africa, And other international radio telescopes are steadily expanding the catalog. With each new detection, scientists improve their understanding of where these signals come from and what they reveal about the universe itself. Some bursts have been traced to galaxies much like our own. Others originate from environments unlike anything nearby. Each one adds another piece to an enormous cosmic puzzle that is still incomplete. The mystery is no longer whether fast radio bursts exist. The mystery is how many different cosmic engines can create them. Perhaps the greatest lesson isn't that scientists have all the answers, it's that they don't. Fast radio bursts remind us that even in an age of powerful space telescopes, supercomputers, and artificial intelligence, the universe still holds phenomena that refuse to fit neatly into a single explanation. A signal lasting only a few milliseconds has reshaped modern radio astronomy. It has revealed hidden matter between galaxies. It has strengthened our understanding of magnetars, and it continues to challenge theories about the most extreme objects in the cosmos. That is the beauty of science. Not every mystery ends with certainty. Sometimes each discovery simply opens the door to an even greater question. Somewhere in the darkness of space, another mysterious signal may already be racing toward Earth. It could arrive tomorrow, next year, or decades from now. When it does, it may once again force humanity to rewrite what it knows about the universe. Because the greatest mysteries are not always the loudest. Sometimes they last only a few milliseconds.